Hey everybody, this is Mr. Beckstrom, and today I want to take a look at, this is an example from section 3.11. This is number 7 in the homework right now, and it says an airline passes over an airport at noon traveling 530 miles per hour due west, and at 1 o'clock p.m. another airline passes over the same airport at the same elevation traveling south at 580 miles per hour, assuming both airlines maintain their equal elevations. How fast is the distance between them changing at 2 o'clock? Alright, so this may seem pretty confusing at first, and problems like this, I like to draw them down as much as possible. So let's call the first airline, we'll call this number 1. We'll call this second airline here number 2. Alright, so number 1 is heading south. It's heading south at 530 miles, 530 miles each hour, miles per hour. Now here, let's call this the airport. So at 2 o'clock, it's already past the airport, right? Because it flies over the airport at noon, and now we're talking about 2 o'clock, so it's gone 2 hours at 530 miles for each hour. So that's going to put the total distance, you just multiply that by 2, and you're going to get 1,060 miles. We're going to be using this in our problem. So passed over the airport heading south at noon, and it's gone for 2 hours at 530 miles per hour, which is totaled 1,060. Now the other plane, plane 2, so this is plane 1 here, plane 2 passed over at 1 o'clock, so this is plane number 2 here, passed over the airport heading due west at 580 miles per hour, so that's the speed there, 580 miles per hour, and now this has only been going that way since 1 o'clock, because it passed over at 1 o'clock, so it's only been going for an hour, so that's going to be 580 miles that it's gone. Okay, and they want to know how fast is the distance between them changing at 2 o'clock. So that they're asking for the rate of change. So they're asking for how fast is this distance changing? Obviously, we know that it's changing in a positive direction because they're getting farther and farther away from each other. So at this point, let's go ahead and start labeling sides and see how this distance here fits into an existing formula. So let's call this side A, we'll call this side B, and we know this is a right angle, and so we can call this one here C. And as we can see, no pun intended, this is a right triangle, and this distance that we're trying, or the rate of change of the distance that we're trying to calculate, is the hypotenuse of that right triangle. So rate of change is going to be the change, the instantaneous change in the C distance over that instantaneous rate of change of time, right? So how fast is the distance changing over time? So this is what we're trying to find out here. And let's see the information that they're giving us. Well, they're giving us that A is equal to 580. The distance, or the rate of change of A with respect to time, that's the speed. That's going to also be 580, because that's 580 miles per hour. And then we have, we have B, which is going to be equal to 1,060. And then we have the speed, which is the rate of change of B, which is going to be dB over dt. That's the derivative of the B with respect to time, and that is going to be 530. All right. Now, the way we link all of these together would be, the easiest way, I think, would be through the Pythagorean theorem. Pythagorean theorem. So that is going to be a squared plus b squared is equal to c squared. Now remember, we have to think back to implicit differentiation. We need to do something so that we get an a dA over dt, a b, a dB over dt, and a dC over dt. And let's go ahead and figure out what this c is, since we're going to end up needing that as well. So just applying the Pythagorean theorem, we are going to get c is going to be equal to the square root of the 580 squared plus that 1060 squared. All right, a squared plus b squared equals c squared, and we just take the square root of both sides. So this is our c here. That's about 1208.30. I'll write down a few digits there. So c is going to be equal to 1208. And instead of doing that, let's just go ahead and leave it as a square root. So 580 squared plus 1060 squared. That's equal to 1,460,000. So I think it'll be a little bit easier to leave it at that, so that we don't have to worry about, how precise we need to be yet. All right, so that's equal to the square root of 146, and then 4 zeros. 1, 2, 3, and 4. All right, so once again, using implicit differentiation, if I take the derivative of this equation with respect to time, I'm going to get all of that stuff in there. So let's do that right now. So the derivative of a squared with respect to time, that's just going to be using the power rule 2a. But since we just took this derivative of something other than time, I also have to multiply that by dA over dt. All right, plus do the same thing with b, 2b times dB over dC is equal to, same thing, 2c times, oops, that should be a t right there. Let me fix that. Not too fast here. It's dB over dt. And this last one here is 2c over, okay. Slow down. 2c times dc over dt. Remember, we're using implicit differentiation, and we just took the derivative of everything with respect to time, so we have to put that extra part there. Now, it's really just filling everything in here and then solving for dc over dt. And let's do that with our calculator here. So, oops. Got my calculator, so it's going to be 2 times A, which is 580, times dA over dt. We said that that was also 580 over here, so times 580, plus 2 times B, which is 1060, so times 1060, times dB over dt, which is the speed, which is times 530. All right, and that's it for that side, so enter. And then to solve for dc over dt, we have to divide both sides by 2 times c. So let's go ahead, there's my c. So we're going to divide this total by 2 times second square root of 146,000, close parentheses, and we get about 743.4. So dc over dt is 743.4. dc over dt is equal to 743.4, and that would be miles per hour. So what that means is that at this distance here, the rate of change between the two airplanes is 743.4 miles per hour. All right, guys. There's a couple different ways to solve this. If you find another way, I'd love to for you to share it on the forums. And if you all have any questions, please let me know. And have a great rest of your weekend. Thanks.